Welcome all to my deep talk about the LLM security. I am Szymon Janowski, Senior Machine Learning Engineer working for DeepSense. And yeah, let me switch to the next slide to show you the agenda for today. So I will start with a short introduction to the topic and why LLM security concerns are valid and important. I will talk about various security risks on multiple levels of LLM-based projects. And finally, I plan to finish with some summary of good practices. And let's start with why should we care and what's actually interesting and growing trend of LLM security. So the LLM market is developing very rapidly. It is estimated that in 2024, it was worth over $5 billion US, and it is projected to reach over 25 billion by 2030. So this means growing at CAGR rate of 37%. And for those who are not sure what it means, that means that LLM's market is growing, is estimated to grow on average by 37% every year. So the adoption of LLM-based applications is astonishing, but one of the pen testing companies, Cobalt, based on their report, found out that 72% of security leaders in different companies rank AI-related attacks as their top IT risk. And what's even worse is that nearly 1/3 of all vulnerabilities in LLM-based systems were classified as high or critical security risk. And only 21% of all serious vulnerabilities were ever resolved. So what it means without all those numbers is that organizations are mostly able to fix easy bugs. Fixing more complex bugs often depends on third-party providers. And all of this shows current landscape of LLM application security. There are not many teams that have good expertise in pen testing LLM-based applications. The race for competitive advantage causes rush deployments without bringing those security teams or bringing them too late. And finally, GenAI software is difficult to pen test, and there is usually no budget for such initiatives. Now let's answer the question how the attack happens. And to understand how we can protect our applications, we have to start with understanding the attack vectors. And to help us with that comes OWASP team. I will start with what is OWASP 10. And it is open source initiative focusing on identifying and documenting security risks. And they are a well-organized institution that helps to identify vulnerabilities. And we want to focus today specifically on their GenAI top 10 list that focuses on LLM-based applications, and it also includes agentic systems. And for us, this is a great starting point to explore the dangers, the vector attacks, and common attack patterns. And I base my presentation on the report, and I really recommend going through it on your own. It's because it's a great source of information. And a short part for self-advertisement. I recently wrote a blog post with introduction to prompt-based attacks. And in the next slides, I will be talking about different types of attacks, and some are already covered in my blog post with examples. So I really recommend to going through those, and I encourage you to read it and test it on your own. Okay, let's start with the prompt injection. LLMs are, of course, sensitive to natural language input, input understood by us, humans, so that same thing that makes LLMs powerful is also security nightmare. Prompt injection just exploits the model by user prompt manipulation. Important thing to mention here is that you might find different name for prompt injection jailbreak. And the difference is that jailbreak manipulates like general behavior. So we aim to trick the model into dropping all safety protocols. On the other hand, prompt injection aims to tamper with specific responses. And in reality, the border between the two is really blurry. They're often used interchangeably. So yeah, but it's worth to know the difference. And other thing worth mentioning here is that prompt injection attack might be inflicted by not using actual user message. When we use chat or modify the prompt directly, no surprise here, we use direct prompt injections, but there is also option to use indirect prompt injection through web pages, emails, or documents. There were already a few quite viral attacks like that, like the zero-click attack from on Microsoft Copilot. And there are several techniques used in prompt injections. I described all of those in detail with the examples in my blog post that I mentioned, but let's quickly go through those to give you a general idea how those work. And I will start with obfuscation, and this is pretty simple concept. Often some words are blacklisted, so how to easily ignore that filter? Well, we could change some of the letters, so the LLM will understand what it means, but the filters won't work. We can also replace some characters with Unicode lookalikes. We can blend languages. We can use emojis, all of that to hide the intent of the prompt. Role-playing. This attack is intended to trick the model by building imaginary environment where assistant behavior can be changed. The aim is to persuade the model that interaction is just hypothetical and not a real-world scenario. Few-shot or multi-shot attack. So let's start with few-shot attack. This is the same technique that is used to improve model output by providing some examples. And in this case, examples will be misleading or malicious. And multi-shot attack term was actually introduced by Anthropic team. And they described it in their article where their models reacted properly on a few-shot attack, and detected malicious intent, but struggled to do the same when they were flooded with malicious examples, usually to the maximum capacity of the prompt. And Anthropic team in their research mentioned that the best way to deal with that was running a classifier before and modifying the prompt before passing it to the actual LLM. Just to go quickly through the other techniques. Recursive injection often uses hidden message, for example, with base64 formatting to re-inject itself later. Chain of thought attack includes a malicious or misleading step-by-step reasoning pattern and the idea is to replace the model's original instructions. And finally, dance, it means do anything now. And this technique uses specifically crafted prompts that I won't show you right now, but if you really want to dig into that, you can find subreddits where people share those prompts. And this approach usually this approach usually combines the techniques I described earlier, like obfuscation, role-playing, few-shot attack, and it's the classic jailbreak example of how to trick model into dropping all safety protocols. Now I'd like to jump into prevention strategies, and these recommendations are based on the OWASP suggestions, as I mentioned earlier. We can constrain model behavior with the system prompt, and it should be like our standard approach. We can also use structured output and validation, and it's pretty self-explanatory. The option to always get expected schema from the model was very important and solidified agentic workflows, so it's also really useful here. We can also include input and output filters. Just a minute ago, I gave you an example how Anthropic team uses it to mitigate multi-shot attacks, but there are many more use cases. Isolated authorization layer. So first, model should have only minimal access privileges, and second, authorization layer shouldn't be controlled or modified by the LLM. Limiting access to external content. I was mentioning indirect prompt injections and how it works, and there is always a chance that malicious content can be hidden somewhere. For example, in the web page on the internet. So what we can do is limit influence of this content on our prompt with separation layers. Human in a loop, of course, and last but probably the most important part, we shouldn't be sure how we won't be sure how secure is the system we are building until we start pen testing it. And this point should be the most important for all of the decision makers in the organization. to really focus on that. And the second security risk focuses on two problems. The first one is presented on the slide. It starts with user conversation. Users tend to share their personal information or classify documents without the guarantee that their data won't be used for training purposes. So what can we do about it? Well, of course, we can educate users and we can be transparent how the application works. Every application should have very clear terms of use and notify users how their data is being processed. And we should also educate users about the dangers of sharing personal information in such systems, and in general, in all of the often free-to-use systems. The second problem is that LLMs are trained on sensitive data. And it is extremely important that during LLM training or fine-tuning, we sanitize and filter input data. It is especially dangerous for model providers that still have to follow some kind of rules and regulations, and such leaks may lead to substantial penalties. So how can extract sensitive information from the models? Well, there are several techniques, and that also involve some of the methods that I mentioned earlier. But the interesting one here is the repetition-based memory spool, also known as divergence attack. And it forces model into dumping cached or memorized contents, usually by very long repetition chain, and also including keywords that can trigger dumping particular information. Like here in the example, on the slide, we start with keyword copyright and forcing LLM to repeat phrase multiple times, and due to probabilistic nature of the next token prediction in the LLM, it can at some point dump some interesting information. Yeah, and for now, I will leave federated learning because I will cover it also later. The second way of interpreting this point is when LLMs are embedded into the application and have access to different contexts. And that way, they can also expose sensitive data. And here, the best recommendation is just to have very strict access control, and there is no easy way around it. Now, supply chain issues. Supply chain issues come from the fact that in most cases we rely on third-party providers. And some guidelines here are also just standard practices in software development when you use external dependencies, like starting with risks, package vulnerabilities. So this is standard in production deployments. You need to have a CI/CD pipeline with some kind of scanning tools to check for both vulnerabilities and licensing changes. But for licensing risks, this point focuses more on AI models licensing. So even some open source models have some limitations, like Llama in their terms of use has a note that you can't use it to improve competing LLMs above certain scale. Same for OpenAI. It also forbids to use models output to train another LLM. And in Hugging Face, you will see various licenses in terms of use. So you have to be careful which model you select and if you can actually use it. The next problem is with outdated or deprecated models. So LLM's landscape is changing really fast, and you might have noticed that applications that we've built some time ago have already outdated models. So general recommendation would be to update those models. That might include or introduce new security fixes, but it's usually more difficult than just swapping it because we have to worry about the performance changes and stuff like that. Also about the vulnerable models. I will talk about it in the next slide, but just one thing to mention here, you shouldn't trust everything on Hugging Face, especially from unknown sources that usually pretend to be official repositories. And now to the fourth security risk, focusing on data and model poisoning. We already covered part of the topic related to PII or sensitive data leakage and data sanitization required to train model on reliable data. However, there is also a second problem. Data inserted during training or fine-tuning might degrade performance, introducing bias or even inject backdoors into the model. And there are several ways that malicious or unwanted data could get in model training data set. And there are a few techniques here, like indirect data injection. So this is actually when user accidentally uploads PII data that might be used later in training. Split view data poisoning is when attacker creates two versions of a data set. One is benign and one is poisoned, but they are basically looking the same. And the idea is that it could exploit version control, package registries, or public repositories. So auditors believe that the data set is correct, but malicious files are being processed. Front running is general term, meaning exploiting knowledge of some event to my advantage. So it's more or less like insider trading. So it can describe different approaches. Like the good example is here, it's like using Wikipedia to inject biased data before a Wikipedia snapshot is created for training the model. So if attacker knows the timing of a snapshot, it can be used to inject the data, even if later it will be corrected by the Wikipedia moderator. Inadequate sandboxing just means that we shouldn't give unrestricted access to different data sources during model training. And now let's discuss how to deal with risk described earlier. So we already talked about data sanitization, so let's skip that. Second thing is verifying data legitimacy. For example, we can do it by tracking versions, hashes, and sources of data sets that are part of AI supply chain. There is also targeted data verification that is used so we can validate if the data affects our model and quality of its output during training process. Data version control to keep full history and easier detect manipulations. Finally, federated learning as a method of dealing with decentralized data sources. LLMs are being expected to be better at highly specialized tasks, but this requires usually confidential data. In that case, we need techniques to get data from trusted sources. One of the ideas is to use federated learning. So like on this picture on the slide, it is a concept when we have decentralized data sources and training happens on client's machines. So the data is always there and it's never leaving its location, but we are updating global weights that are stored somewhere else. And yeah, so let me move to improper output handling. One of the things that I mentioned at the beginning was that structured output is a good way to deal with some prompt injection attacks. However, prompt output handling goes beyond that. There are several scenarios where unsanitized LLM output can be risked. And for example, it can be like directly executing LLM output, generating SQL queries, or maybe like DSL-like structure to execute commands, or even generating JavaScript code interpreted by the browser that can result in cross-site scripting. And here we have an example how cross-site scripting happens. And it can occur when attacker injects malicious scripts, usually JavaScript code, into a web page. And on the slide, you can see example flow with scripting, with script stealing cookies from the user browser. And in general, there are a few recommended ways of dealing with such risks. Of course, we have to validate and sanitize output of the LLM. We also have to encode output. Dangerous escaping characters can be encoded into safe representations, and there are several libraries like that for both Python and JavaScript, for example, DOM Purify for JavaScript. Here is the example where you can see how this text can be encoded and related to other prevention strategies. It's better to parameterize pre-configured statements like narrowing down the SQL commands that LLM can use. And it's really good to have robust logging and monitoring system to detect any anomalies happening in the application. You might have seen Twitter post some time ago that the developer allowed, I think it was Cursor, run the YOLO mode that basically allows agents to run all commands in terminal without human in the loop. And it removed its production database. And this is exactly the main risk identified here. So restrictive roles and permissions are a necessity in such systems, mainly because of LLM's hallucinations and prompt injections from malicious users. But let's start with common risks around excessive agency. Excessive functionality, easy to explain, just restrict functionalities of your tools and remember to remove unused ones. Now about the excessive permissions. So have proper permissions set for tools and group of tools. And now a little bit more about the last part, excessive autonomy. Especially in initial phases of the projects before the whole agentic system is thoroughly benchmarked, it is recommended to include human in the processing loop. And especially for potentially critical action, have someone to supervise the agentic flow. And the Twitter example that I mentioned at the beginning wouldn't happen if the user left the default settings that require human intervention when running commands in shell. Prompt extraction or leakage. So let's be honest, prompts are becoming equally important and sensitive as model weights. Having good system prompts is usually the main expectation in LLM-based projects, and that means that we should also be very careful how the prompts are stored, and if the prompts can be leaked through some kind of communication interface with the user. And there are several techniques used with prompt injections to get some kind of information about system prompt. It can be role play. This is a basic technique I already mentioned, but it can be used to extract some kind of prompt information. Same works with dance. Something different from previously described attacks is fill in the blank leakage. And the general idea is that you can start with a phrase like, as an assistant, I was instructed to. And the model might not recognize it as a harmful user message, but will try to fill the rest of the sentence, often leaking some parts of the system prompt if you find the right sentence. Other example, also displayed on the slide, shows output manipulation. So often third-party models have some kind of verification at the end. It may be even simple pattern matching. However, when you ask the model to return a poem instead of the exact prompt, you can still often get the general information about prompt. And I did several experiments like that with some toy examples of agentic system, and it's surprisingly effective. And sometimes it's really difficult to guard the system prompt as a developer. So let's now talk about general risks. Of course, we can expose sensitive functionality like system architecture. We can also expose internal rules. And as I mentioned, it might give our competitors some kind of valuable information about our system. We could also reveal some filtering criteria that might eventually help design better prompt injections to even better exploit our system. And finally, let's discuss how to prevent different prompt leakage. So first of all, don't include sensitive information into prompt. You can keep this in the agent context, but make sure it's not leaked into the prompt. The second point, it is quite interesting because the OWASP team recommends that we don't use LLMs for PII checks. Why? Because LLMs are prone to prompt injections, so it's safer to have non-LLM alternative for filtering and for the checks. So we often call those checks guardrails, and the most valuable ones are the ones that are outside of system prompt, of course. And I feel like I already mentioned it during this presentation when discussing other point, but privilege management or other critical control mechanisms shouldn't be delegated to the LLM. And now a little bit about RAG. I really like this beautiful depiction of RAG from RAG from Scratch tutorial. And at this point, I don't think that I have to explain how the RAG works, but it also makes sense to cover it. And it is already covered in the OWASP report. And still, there are several risks related to RAG systems, like, for example, unauthorized access and data leakage, but also cross-context information leaks that can happen in multi-tenant environments, where you have to be careful about the scope of the information when you're trying to extract. Now, the problem of federation knowledge conflict is quite interesting because it means that information conflict can happen in LLM. It can happen with multiple sources contradicting each other, or with LLM having different training data that the one retrieved from the RAG system. And the best way to deal with that is to review the group together data sources and monitor RAG behavior through integration tests with different scenarios. Now, embedding inversion attack is honestly really difficult to pull off in a real-world scenario because it requires direct access to vector database. But there are articles showing that it's possible to do partial embedding inversion and guess metadata, like, for example, gender or race, of course, when it's relevant in the chunk. It is also possible to extract back of words from embedding, and even sometimes, in some cases, whole sentences in the correct order. So something important to keep in mind, that embeddings are not encrypted information, and we shouldn't treat it as such. And the data poisoning attack I will skip because we already talked about it. Just verify your data sources. Here I want to show you this this very cool example from OWASP document that shows behavior alteration and how it may not be always intended result. Here we see empathetic response that might be expected, and the response with augmented retrieve context. So it is something also something that we usually don't think about it, but something worth having in mind when designing such systems. It's worth monitoring those cases. Now about misinformation. Misinformation is actually quite easy to explain because we all know how LLMs can hallucinate. And here we also have several risks like factual inaccuracies, unsupported claims, misrepresentation of expertise, so meaning that model only provides an illusion of understanding the complex topics, or unsafe code generation in some specific cases. And how to prevent misinformation? Well, we can split it into two groups. RAGs and fine-tuning will generally improve LLM capabilities and limit hallucinations. Validation or human in the loop can do the same. And finally, second group is more proactive. So we want to educate people how LLMs actually work, and communicate clearly that AI-generated content cannot be fully trusted with verification. Okay, finally, let's move to the last threat, unbounded consumption. And actually, here, unbounded consumption can be understood from two perspectives. One, easier to understand, some LLM-based chatbots can be flooded with messages, so it can cause some inefficiencies in the whole agentic system. So it's basically denial of service attack. Sometimes it might not be even the long message that's causing the problem, but it can be targeted message that triggers particular tool calls. Ultimately, agentic framework often implement agentic flows as graphs that can also be exploited. And now let's recognize denial of a wallet. So attacker can exploit cost per use model, often used with different cloud providers to generate extensive costs. Now there is a second perspective. Honestly, I'm not entirely sure why it was grouped with the unbounded consumption, but it's also really important because it talks about replicating model, whether it's to create shadow model, like it's not like a knowledge distillation, mimicking original model behavior, or side channel attacks that exploit model architecture. And what are prevention mechanisms? Well, for example, limiting exposure of lodges and log props. And OpenAI already started doing that with their latest models. Other mechanisms, rate limiting, timeouts, resource allocation management. Of course, we have to also remember about logging, monitoring, and anomaly detection, but also watermarking. Sorry. Also watermarking. Some time ago, for example, Google introduced SynthID for Gemini models specifically designed to watermark AI-generated content like videos, images, audio, and even text. So it is possible. So now the summary. Now, if I had to give you some final guidelines regarding security threats, for usual scenarios that we implement for our clients, I focus on those few points. Multiple times on the slides, you saw input and output validation filters or sanitization, and all of those are really important. Some of the stuff you can do manually. It depends on the problem. Sometimes it's worth to use some guardrails. For example, quite popular guardrails AI library. This is this green icon below. Generally, it's very important to control what comes into the LLM and comes out of the LLM. Using models from trusted sources. I'd say that with current domination of third-party models, it's not that dangerous, but still it's definitely worth updating those models in the applications. Now, isolating security layer, especially authorization from the LLM. In general, it's important to keep critical information in context that can be passed between agents, but not used in the LLM call. So it's good practice to inject it separately and control it in fully deterministic manner. Minimize number of tools, its features and permissions. So just a friendly reminder that the most safe implementation is the most simple one. And finally, test your systems. So I can recommend to check out few frameworks like PromptFu, DeepTeam, or Pirate, coming from the team that created maybe a more popular deep level framework. I was talking about the Deep Team, not the Pirate, sorry, if that was confusing. All of those frameworks, anyway, are quite interesting. PromptFu and DeepTeam implemented plugins that directly cover OWASP top 10 GenAI vulnerabilities. So, of course, only those that can be tested in some scenarios is quite difficult to simulate it. Still, all are very solid frameworks. I only use PromptFu, but I run some tests with the others, so I encourage you to test it on your own. Yeah, and that's everything from me for today. Thank you, and see you next time.